Good afternoon, everyone. Today we're going to do a video on similar triangles. So, for example 1, we have a triangle inside a larger triangle, and so we see that the right side of the angles are equivalent, and likewise the left corner angles are also equivalent. And so we can use the strategies that we've explored that pertain to similar triangles. And so, on the left side, we have that the left side length of the smaller bottom triangle is 36. And this second part, we'll call it, is of length 24. Now, keep in mind that we have strategies for similar triangles, not for triangles and rhomboids here. So we have to keep in mind that this entire side length will be 24 plus 36, namely 60, okay? So we know that the ratios have to be in proportions to one another. And so the ratio of the smaller left side length compared to the larger left side length, that is to say 36 to 60, has to be equivalent to the same thing on the right side, the ratio of the smaller right side length of the smaller triangle, and so that would be 40, compared to the entire right side length of the big triangle, which is going to have, that's an awful, so sorry, there we are, something like that. This entire side length, keep in mind, is the sum of 40 and this additional top piece at the end, namely x plus 40. And so the ratio of 40 relative to x plus 40, okay? And now we're being asked to find this little part, which doesn't exactly have itself as a ratio, but is involved in this proportion, and so this will enable us to use some algebra and solve for x, which we are ultimately looking for. And then later on, since we have the proportionalities written down, we can use that for 70 and for y in our second step. So if we go ahead and do some algebra that I'm sure you guys have all done before, been privy to before, let's multiply first both sides by 60. So now we get rid of the 60 over here, so now we have 36 is equal to 40 times 60, that's 2400 over x plus 40. And now, let's use a different color. We want to isolate the x, so we don't want it in the denominator, so let's multiply both sides by our beloved denominator, namely by x plus 40. So that'll get rid of the denominator, which is what we hoped would happen. And on the left side, we have 36 times x, and so 36x plus 36 times 40, that is 1440, is equal to 2400, and now we're back to our basic grade 7 algebra. So subtract 1440, subtract 1440, and so we have that 36x is equal to, would be 960, and then dividing by 36 on both sides, we get that x has a value of 360, 720, 1080. Might you need a calculator for this one. Feel free to use a calculator at home too if you're following along. We have 960 divided by 36, just 26.6 repeating. 26, if we want to round it to one decimal place, 0.7. I didn't put any units, so let's just leave it as generic units. So x is 26.7. So that is our x value over here, okay? And now, since all three sides are, after all, the sides of similar triangles, we can also apply this exact same proportion to the horizontal sides, or at least they look horizontal. So we were always measuring the smaller triangle compared to the bigger triangle. That's always important to keep in mind. So it's always a smaller triangle compared to the bigger triangle. So let's stay consistent with that idea. So we'll have the smaller triangle, which has top length y, over the bigger triangle that has top length 70. This would be an easier problem to solve. So for part 2, for the y value that we're looking for here, we're only going to look at this proportion. And so if we want to write it again up top to clean it up, y over 70 is equal to 36 over 60. We can even simplify 36 over 60. We can divide both of those numbers by 12, and we get 3 over 5. And now, since all we're looking for is this y value, we can multiply both sides by 70 to get rid of our denominator, multiply 3/5 by 70, and we'll find our solution that y is equal to 3/5 times 70. You can do that out for yourself. 70 divided by 5 is 14, and 14 times 3, so let's do that out. 70 over 5 simplifies to 14 over 1, and now 3 times 14 over 1 is 42. And so there is our second value. So our x is 26.7 over here on the top right side, and our y, our smaller triangle's top side, has length 42. Okay? Now in example 2, what we have here is a nice right angle triangle that's kind of flipped over and magnified down on the other side down here. Now you notice that they are both right triangles since they both have a 90-degree angle. And since all triangles have 180 degrees collectively with all three of their interior angles, the fact that they're both right angle triangles and that these two angles are identical implies naturally that their third angle has to be the same, so we don't really have to look at that. It's applied since all triangles have a sum of 180 degrees within their interior angles. And so now, if we're going to look at proportions for ratios, what we're going to have is the hypotenuse would be these two sides. The, let's say, vertical side will be these two, and then the bottom side will be these two, okay? So now we can write our proportions the same way that we did over here for similar triangles, because these are indeed similar triangles. They have the same interior angles, right? So we can write that 40 over 100 is in proportionality, or in proportion rather, to, again, it's smaller triangle over bigger. Encouraging you to keep that in mind. Smaller triangle over bigger, making sure you don't flip-flop those proportions. So it's equal to the smaller, again, over the bigger, so 15 over our unknown value over here. And now we're back to basic algebra. We have our unknown in the denominator, so let's multiply both sides by that unknown. This would run into a problem if this value was 0, because we had to divide by 0, but clearly this height is not 0, or we would not have similar triangles. We would simply have a line. So that's an easy one. So now those goes away. So on this side, we have 40 times this unknown value over 100 is equal to 15. Now we can multiply both sides by 100. I'm sure you guys know how to finish this one off. 40 times the unknown value is equal to 1500, and dividing both sides by 40 gets us to our solution. Excuse me, used to writing x's. Our unknown value, this question mark, is equal to 1500 divided by 40, which will be a little bit short of 40, so it'll be 37.5. And there we have it. And since we have units in this diagram, let's write that our vertical distance, vertical length here is 37.5 meters long. And there we have it. Okay. So it's always using the arguments of proportionality. If we can argue appropriately that our triangles are similar, making sure to always stay consistent with how we orient our ratios. Okay. I hope this helps. If you guys have any comments, suggestions, if I did anything that was horribly confusing, please let me know in the comments. Thank you so much for watching, and have a great day.